Hello and welcome to this month's Serverless London meetup. This time we've got two talks. One by James Beswick, who'll be talking about building event-driven systems, and then a colleague of mine, Sarah, will be talking about using AppSync. First up, James, you can take it over.
Great, everybody. Well, thanks for inviting me to your session. Today, I'm going to be talking about decoupling serverless workloads using Amazon EventBridge. My name is James Beswick. I'm a developer advocate here at the AWS serverless team. So I represent services like Lambda, EventBridge, step functions, and others. Before I was a DA, I was a product manager for a long time and also a software developer for quite a few years as well. But if you have any questions about serverless products or usage at all, feel free to reach out to me anytime through email or Twitter. I'll put my details at the end of this deck. So today, I want to show a few different things. I want to talk about some of the challenges that already exist with using microservices and how EventBridge can help solve some of these. Then I'll cover some integration patterns, and we'll also talk about extending the capabilities of EventBridge with the cloud and SaaS partners. And then finally, I'm going to show you how to decouple architecture using events, using the serverless application model, also known as SAM. And we'll have some demos along the way. There are code links on some slides, but this link at the bottom of the page just here, s12d.com/decoupling, contains a resource page that contains everything. So let's have a quick review of some of the challenges that we see with microservices. So when you first start building microservices, you often have a simple architecture like this. It starts where you have an order service and an invoice service in this example. And in this initial stage, this is all very simple and it's more or less perfectly decoupled. But what tends to happen is that when you have a successful or popular service, people then want to integrate with your service. So in this case, we now have a fulfillment service and a forecasting service that comes along and wants to integrate with the order service. And so with this means the order service has more responsibilities, more complexity. And it also means that it has to understand retry semantics for each service, maybe bundle in an SDK for each as well. And if each downstream service publishes an API, then the order service team is then responsible for talking to each of them. So what happens here is the order service team ends up spending less and less time on writing features that are useful for their servers, and more time in terms of integrating work from other teams. And so long term, more and more systems out there need data from the order service. And in this model, these teams end up being blocked until the order service team can implement the integration. So all of these teams end up not being able to operate as independently as they once could, and it creates unnecessary friction in the process due to the integration cost of hooking these services together, and it slows down development. And you'll notice that what was once decoupled now starts to look kind of monolithic. It's all starting to look how it did before microservices came along. And so here's the same e-commerce application example with some additional downstream services I added. Now, in the happy path, everything works just fine. So the order service triggers the invoice, the payment and forecasting services, and then payment, once it processes, triggers the fulfillment service, and then that triggers the shipping service. And so when everything works as expected, this is fine. But what you'll find is that in this model, exception handling can start to get very messy. So what happens, for example, if the fulfillment center here is unable to find the product on a shelf and has to reverse an order? Well, they may have to then alert the invoice service to make an adjustment to something that's already been created. They may have to tell the payment service to issue a refund or a credit or a partial credit, depending on how the payment was made. Then you may find that shipping was already told, so they have to make an adjustment to invoicing. And maybe the forecasting service just doesn't accept these kind of adjustments, and so it has to be manually changed by somebody, and it's just wrong until that happens. And so this is just one possible problem in the remediation path when any type of error occurs. And really, even in a simple system like this, you find there's lots of different problems that can occur. And so this type of model actually ends up being fairly fragile when it comes to handling any sort of issues. Now, those are some of the challenges, but really there are many benefits to running a microservices model. In a well-designed microservice architecture, you can maintain loose coupling between all of the different services. Also, microservice-based systems can be significantly more scalable. You can maintain enormous scale, and in fact, many AWS services under the hood are microservice-based precisely because of this. You can build systems that are much more extensible because new features and applications can consume events without impacting other systems. And much of the complexity of large systems can be easier to manage in a microservices model. And of course, you can design for higher levels of availability with many patterns available that can help you develop resiliency and fault tolerance. So we have Amazon EventBridge as a service that was launched relatively recently in the last couple of years. And this is a serverless event bus service. So really, it makes events first-class citizens within AWS, and it helps you to ingest and route events from SaaS applications, AWS services, and your own systems. It's not an entirely brand new service. It evolved from CloudWatch events, so it already processes trillions of events every month in many different regions. So the most important features of using an event bus from the point of view of decoupling your systems are these. It provides an endpoint where an event producer can send events to, and then the router then manages directing and filtering those events to the appropriate downstream consumers. Consumers can then get the events they care about reliably, while the producers remain completely decoupled. And so from the previous example that we looked at with the order and invoice service, introducing an event bus is actually fairly simple. The architecture looks like this. The order service sends events to the bus, which is then configured with rules that determine which downstream systems get those events. Some targets only care about certain events, whereas other targets will want to receive all events. Either way, the router takes on the complexity of ensuring that these events get propagated appropriately to each downstream service. So let's take a look at some integration patterns that you can build using EventBridge for your serverless applications. EventBridge accepts events from event sources, and these can be any one of 95 AWS services, your Lambda functions, applications, SaaS application providers like Auth0, Datadog, or PagerDuty. And there are three types of event bus. There's a default event bus, which is always available in every account where AWS events are routed to. There are custom event buses, which you can create for your own application use cases. And there are SaaS event buses, which are created for when you configure SaaS application integrations. There are many targets potentially available too, including Lambda, Kinesis, step functions, API gateway, EC2 instances, SNS topics, SQS queues. You can also route events to buses in other AWS accounts. So this flexible and non-prescriptive design allows you to create a very wide variety of different integration patterns. And there's three of them I want to show today that I think are kind of interesting. So the first example is a scalable webhook. A webhook is an HTTP endpoint that's callable from another service, which could be another microservice or a third-party application. Webhooks do have some problems. So they're often public endpoints that can receive sudden bursts of traffic from SaaS providers or other systems that are providing you with data. And if the backing application that you have cannot scale to receive that traffic, sometimes you can experience an outage when traffic surges occur. So in this case, the caller of a webhook may not know that you had an issue and doesn't know about it needs to retry or handle any errors. And so you can lose messages in that case. So this is actually a fairly elegant solution to that problem. You use EventBridge in the middle, and essentially your HTTP API endpoint then puts the message directly onto the event bus using a service integration. We then pass that message along to an SQS queue, and that gets routed down to a consuming application, such as Lambda in this case, but it could be any one of any number of different systems. So the benefits of this are that you can change the destination of the webhook very easily by adding new targets. You don't need to change anything before you get to that point. And you can also control the rate of consuming events in the Lambda function in this case by changing the batch size of the SQS integration. And also you can control concurrency controls with Lambda as well in this case. So if you really wanted to scale up quickly, Lambda can do that. So under the covers in this example, this is what it looks like in a SAM template. So SAM is the serverless application model, and it can help you model your applications using code. So on the left-hand side, we have an HTTP API configuration, and this uses this open API specification shown on the left-hand side. So what this does is it defines EventBridge as a target, and then it defines very simply in the detail that it's going to take the payload passed to the HTTP endpoint and put it into the detail of the event. So on the right-hand side, you then look at the rule, and the rules in EventBridge are really critical because they evaluate all of the traffic going through the bus and decide where that traffic's going to go. So in this case, this rule defines that any traffic with a source of my webhook will be routed to this target of an SQS queue that's defined in the template. So what I'm going to do is I'm just going to stop here and show you in practice how this works. So I'll switch over to, I've got Cloud9 running here. Now, I've already deployed the 3 examples that I'm talking about today to help save time, and I've downloaded and Git cloned the code into my Cloud9 instance here. I realize it's a bit small on the left. But the key thing to see is the template. Oh, I think I disconnected from my Cloud9 instance. Okay, the key thing to see is the template for that first example, the HTTPI webhook. So here there's the Lambda function. This is doing nothing more than consuming events off an SQS queue, and the code itself is just a logger. It's just receiving the event and logging it out. And then a little bit further down, here is the HTTP API endpoint. So this again is including that open API specification we looked at. And this is a really simple example. It's just taking the payload and putting the whole thing into an event. But you could do more sophisticated things in terms of evaluating what's being passed to the API endpoint. And then further down, there's an API role that allows this all to happen so the different services can call each other. And here is the rule that we saw on the slide, looking for source of my webhook, routing that traffic to the SQS queue. And once again, there's another policy here that allows that to happen. So this is now already deployed. So I can show you how this works. If I go to Postman, I've already taken the API endpoint and put it in here. I realize it's really tiny, but that's the URL that we have to this webhook. Now, if I send a request to this webhook, you'll see that we get a 200 response back indicating that call was successful. Now, the body itself is really nothing that important. It's just a piece of JSON saying name is James, but the response we get back indicates that that's been put successfully on the event bus. So that will be passed to HTTP APIs, that passes it along to EventBridge, which then pushes it to an SQS queue, and then finally sends it to our Lambda function. And if we look at that Lambda function over here, I'll go to the configuration tab, sorry, the monitoring tab, and look at see if it was called successfully. Just wait for that to load. And if this was called successfully, we'll see one log stream indicating the payload. And there it is there. So you see this is the payload, and in there that says my name is James, which was what passed in from HTTP APIs. Now, when you're sending just one request, of course, this isn't that interesting because you could easily do this any number of different ways. But what happens when things either go wrong or you get lots of traffic? Well, first of all, let's do this. Let's go back to my Cloud9 instance, and we'll use artillery to send more traffic. So I can type, there we go. So go to the first example. I'm going to use this test.yaml artillery configuration. So we can use artillery to call the endpoint lots of times and provide a small load test just to simulate lots of traffic. So what I'll do is I'll say artillery run test, and that'll start sending requests. Now, what I did in this Lambda function is I did something to slow this down, so it's not really able to keep up with the traffic I'm sending it now. In here, we've got a delay where it's essentially a brief delay of 2 seconds where the Lambda function just has to stop for 2 seconds. And I've also restricted the concurrency to 1. So each request we're sending to the API endpoint can only be processed one at a time, and it's taking 2 seconds at a time. And so what you'll see when we go to the SQS queue behind this is this now has 77 messages that are being queued up and processed for this Lambda function. Now, at the same time, if I go back to artillery, there were 100 requests sent, all with 200 responses, and there were no problems there, even though our backing system is obviously slowing down to catch up. Another part where this can be useful as well, in this piece of code, I've introduced this environment variable called failure%. And all this is essentially a value where it simulates a failure. If the value is 50%, then every other time the function will throw an error. So if I go down to my configuration and then select environment variables, here's the failure rate %. I'll change that to 50%. So every other time that it's being called, it's going to throw an error. Now that's immediately effective. And so back in the CloudWatch logs, if we go back to those, we should see more logs appearing. And we'll start to see errors coming through as well, because every other invocation is now failing. Now, because we're using SQS, any error messages are being passed back onto the queue, so we're not losing those messages. And so all of this resilience we're getting from the extra traffic, and also I've now got my flaky code that's failing every other invocation, is being handled by this SQS queue. All the meantime, the caller of the webhook is not aware there's any type of issue. So I think this is a really simple solution to a fairly complicated problem. And all you have to do is introduce EventBridge in the middle with an SQS queue. But have a look at the SAM template for this to see this in a little bit more detail. Now, the next demo I want to show you is responding to workflows. So this can help you when you've got any type of workflow in place using step functions, and you want to build some sort of application that is responding in real time to things that are going on within the workflow. So in the opening example, I showed an e-commerce example with these 6 services. And some of these services, like payments, have their own complex logic internally. So if you think about payments, payments have different types. You've got cash, there's check, there's credit, and they can succeed or fail, or they can be reversed, or they can be partially successful, or they may take a long time to complete. In the case of checks, sometimes they can take days, and it's not seconds or hours in the case of credit cards. So the payment service would be a really good candidate for step functions, given the complexity of the workflow. And so a workflow that emits events for all of the different statuses is really useful for flexibility and extensibility and allowing other services to respond to changes. So in the case of a payment service where we have a workflow and we wanted to do something, if credit card payments failed, for example, we can actually start listening for events where that happens and then take action accordingly. So when you integrate step functions with EventBridge, it allows you to do exactly that. And so as state machines begin and end in step functions, they can emit events to the bus. Now, there's no cost for doing this since the events are already sourced from another AWS service. Now, if there's nobody listening to the event today, that's fine, but it gives you the capability tomorrow to allow other teams to build on what's happening within the infrastructure. So the GitHub repo shows how you would deploy a step functions workflow, emitting events to EventBridge, and then creating rules for a Lambda function to consume those events. Now, if we dig into this a little bit, what you'll see here is the events that are emitted from step functions look like this. So the detail type shows a status change. It provides relevant ARNs, timestamps, inputs, and other data. So to consume an event that's interesting to your app, such as the credit card failure situation, you simply have to build a matching rule to match these attributes. Now, unlike the order invoice example that I showed earlier, this allows integrations without any code changes in your software at all. It allows other teams to build these services based upon your workflows. And as the event producer, you're enabling that capability by creating the event, but you're not responsible for their application. So let me show you how this one works. If I go back to my Cloud9 instance, which is just here. So I'll first go back to the template. So this is in Cloud9. I've just cloned the same repo, and the SAM template shows the application that was deployed. So in this template, similar to the last one, we have a Lambda function, and all this is going to do is log out the event. The rule is really the important part here. It's going to listen for any events with a source of aws.state. So there's literally everything coming from step functions. You could be much more granular in real life. And then it will target that consumer function, the Lambda function, with that information. And then finally, there's simply a permission that enables the event bus to invoke your Lambda function. Now, what's interesting about this is I haven't yet built the step function state machine that's going to cause this to get triggered. I've simply deployed this code. So if I go over to step functions here, there we go. There's no state machines currently in my account. I'm going to create a new state machine, and I'll just use the hello world example that's available in the UI. I'm going to just call it my state machine, and I'll create that state machine. And that just takes a few seconds. Okay, so that's now available. I'll create one execution. This state machine doesn't do anything useful, but I'll just put a comment, hello London, and I'll run the state machine. So this is a very simple one. It starts, goes to hello, goes to world, and then ends. And you'll see that then succeeded to be executed. So what happened here now is the step functions state machine was passing events for each of those state transitions to the event bus. And that rule we created is listening to every one of those events as they were being passed into the event bus. So if I go to Lambda and I look at the Lambda function that was deployed, which is this second one here, and you'll see that this code is actually doing nothing more than logging out the event that's being passed to it. But if we look at the logs for this function, I'll just look at logs in CloudWatch. You'll see this will be called multiple times for each one of the transitions in the state machine. So we've got 4 different invocations there. I'll just open the first one as the example. And this is all the information passed by step functions regarding this state machine. And in there, you should be able to see, if I can find it, the Hello London payload that I passed in. So this is really simple, actually, because it enables you to build applications for step function state machines that may not exist yet. So if you want to look at if you want to capture events from those flows to use in your own applications, this approach is actually a fairly easy way to do it. Okay, finally, I want to show you how you can integrate this with CloudTrail. So the third example uses events are emitted to CloudTrail. And so many AWS services and actions can emit events to EventBridge via CloudTrail. And this includes services like AWS Batch, Code Build, Glue, IoT Greengrass, and many, many more. It also includes actions that happen in the console, such as sign-in events or when tags are changed on AWS resources. So you could use this to build a serverless workflow to take action when a user logs into a console, for example. So beyond these supported events, you can also use EventBridge with services that don't emit events by using AWS CloudTrail. So EventBridge can listen to any events that are logged naturally, but all events you'll see that delivered via CloudTrail have a detailed attribute of AWS API call via CloudTrail. So this opens up a really interesting variety of possibilities of what you can build as integrations. So one of the examples I really think is interesting is allowing multiple S3 buckets as an event source for a single Lambda function. So when you use the default integration between S3 and Lambda, you cannot have overlapping subscriptions. If one bucket is publishing all events to a Lambda function, you cannot create a second Lambda function with exactly the same subscription for the same bucket. However, if you enable CloudTrail logging for your S3 buckets and then consume the event source in EventBridge, you can use overlapping subscriptions. And that means you can have several buckets that are triggered by one or more Lambda functions or any combination of Lambda functions that you choose. You can also have the same prefix or the same suffix triggering multiple Lambda functions. So after enabling CloudTrail, you then create an EventBridge rule to define which bucket events should trigger the function. So in this example, you'll see the event pattern filters for a put object, and then it names 3 buckets that it's interested in: my sales Jan, my sales Feb, and my sales March. And you can modify those simply by changing the rule. You don't need to change anything in your code or in the Lambda function itself. So you can take this a step further by using content filtering syntax in EventBridge rules. So imagine, for example, that you need to invoke a Lambda function when an invoice is saved in a monthly sales bucket. And these buckets follow this naming convention of my sales Jan, Feb, March. But my sales April and May and June, they don't exist yet. So you want to be able to make sure that your application continues to work as new buckets are created. And so by actually integrating it this way, you can do this. You can build applications for buckets that aren't yet being used. So CloudTrail, you'll find logs additional information about S3 events as well, such as object size, principal, source IP address, and many other attributes. You can filter on any of these attributes using complex rules to match specific sets of events. And then your rules can trigger Lambda functions, step functions workflows, or any other target that you need. Take a look at this code repo to see how this works in detail, because this pattern allows you to decouple event sources from event consumers. And it can make it very easy to work with existing buckets and can help when you're creating microservices serverlessly in larger applications. I'll show you a quick demo, though, of how this can work. So I go back to my Cloud9 instance. This is the third example that I cloned from that repo. I'll open up the SAM template. So in this case, it's a little bit longer. We've got 2 buckets. We've got a source bucket that we're interested in monitoring, and also a logging bucket that's used for CloudTrail. These are defined in the resources here, and then there's a bucket policy that allows CloudTrail to write to that logging bucket. A bit further down, we defined the trail that we want to use. And so one thing you want to be careful with CloudTrail is if you have a very, very busy active account, you can create lots and lots of events. So you want to be very specific about the events you're capturing for your application. And then further down, we simply define the Lambda function. This is another logger function that just takes the event and logs it out. And then finally, here's the EventBridge rule, just capturing events from S3 with a put object event. So to see how this works, if I go to my S3 bucket over here, just open up my S3 console, and we'll search for the bucket that was used for this deployment, which is called EventBridge. EventBridge source J Beswick. So right now the bucket is empty. So what I'm going to do is I'm going to put an object into that bucket. And I'll do this just by using the CLI. So we'll clear this. Now I'm going to create a test file. I'll just call it touchtest.txt. And then we'll upload that to that bucket name. That uploads that text.txt. So I go back to the bucket now, you'll see if I refresh, that file has now arrived. So what happened here is we've now created this object in S3, that's triggered an event in CloudTrail, and then that goes to our third Lambda function that was deployed. I'll just switch over to there. And if we look at the logs for that third function, we'll see that this Lambda function has been invoked by that put event. Let's wait for that to load up. And there's the log file. And it contains that CloudTrail information about that particular object, the put event, who caused it, and many other things. And you can filter on any of these attributes within your EventBridge rule. So I just wanted to spend a couple of moments talking about SAM, because we've seen a couple of SAM templates used in these examples. And there's some real benefits of using SAM when you use EventBridge. First, you can build smaller microservices that communicate using events, and you can deploy those using SAM, which really helps with simplicity. If your organization has teams of developers working on separate services, it allows each team to be in control of developers working on separate parts without needing to step on each other's code. SAM can also make it safer and faster to deploy new versions and new features of your software. And since the many developer teams are now developing more features and services more often, you can build microservices that emit events to each other, which helps with extensibility. So this really goes back to creating things that are easier to understand, easier to maintain. So just to give you a quick example of this, I built an example last year of a document index application. This was the kind of monolithic SAM repo with all of these different Lambda functions and buckets and things going on. And so what this did is it took files that are arriving in a document bucket, extracted the information from them based upon whether they're PDFs, Word documents, or JPEGs, and then put them in another bucket for indexing. And although the application works fine, it's actually hard to extend this to other file types without making changes to the entire application. It's fairly tightly coupled. So I then took this example and moved it into a different application using EventBridge to communicate between the microservices. And the microservices are deployed using SAM instead. And what's interesting here is that now the S3 buckets are communicating through CloudTrail, so we can have more than one bucket, or we can change the list of buckets we're listening to. That's then being put onto the event bus. And then the application itself is separated out into parser functions, converter functions that all listen to the bus and put events back onto the bus. So if I want to make a change to the parsing logic or listen to new files, I just have to add a new Lambda function as a parser. Also, I'm using Elasticsearch here, but if I didn't want to use that and change that in the future, I just change the target on the event bus. I don't need to make really very large changes to the application at all. So there's much more information at the URL at the bottom of the screen that shows how this works, but this is how you can really take apart much larger applications. And I realize we're a bit tight on time, so I'll skip over this section, but just as a quick recap on this, I mean, really, EventBridge can help you decouple applications, especially in enterprise environments, as you're starting to get larger and larger in the code that you're producing. It can really help with scalability, as we saw in the webhook. As you get lots of events, EventBridge will scale up to receive those events, and then you can use services like SQS to then queue up or smooth out the traffic as it goes downstream. Also, extensibility. I think this is a massively important factor in how you build applications now, because so many new features arrive in your application that you don't know you're going to be building. So any type of architecture that can help you with this, I think, is a real win for software developers. The security model is also very granular. If you go through any of those SAM templates I showed, you'll see that we can be really precise about how you can listen to events and who you can consume those events. And also, if you're using SAM for all of this, you can then accelerate your deployment. It makes it much easier to deploy things more reliably instead of using the console. So thanks for that really fast demonstration of these. I hope that was very useful to you. My name is James Beswick, and I'm a developer advocate here at the AWS Serverless team. So don't hesitate to ask me any questions at all if you have any questions. Thanks very much.
Thank you very much, James. That was a great talk. We do have a few questions that have already come in. I'll start with one from Daryl, should pop up on our screen. But he was just basically asking about EventBridge API destinations. I think you wrote an article maybe last week about this topic.
Yeah, so this is really exciting. I'll see if I can dig up the article and I'll paste it in the link. But API destinations essentially enables your bus to reach beyond the AWS cloud. So you can send events out to SaaS providers such as PagerDuty, Splunk, Slack, really anybody who has any type of API endpoint that you want to talk to. One of the interesting features of the service is that it also throttles events. So if you have a very busy application, you can set the number of messages per second that you want to communicate to that provider, so you don't accidentally just swamp them with traffic. It'll queue up messages as they arrive for up to 24 hours as well. But you can manage the whole thing through CloudFormation and in SAM, and setting it up can be really easy. So in the blog post, I've got a few examples, but you can get fairly creative because you can send messages to Stripe or Slack integrations or pretty much anything you care to. But that's available in all the regions where EventBridge is working, and it's available in GA today.
There's a similar sort of question from Phil about whether you think AWS will start deprecating point-to-point service integrations in favor of just using EventBridge.
Typically, we don't deprecate services or features within AWS because many customers are building infrastructure that's based upon how things currently work. But definitely, as EventBridge starts to accelerate in popularity, we're thinking about how we integrate with lots more services internally and also trying to make it easier for customers. So if you have specific services or integrations you would like to see, definitely contact me because I talk to the product teams very frequently and they're always interested to know about what customers are trying to integrate with EventBridge.
We do have another question from Phil. I think this was one of your early examples about why to use EventBridge in the middle instead of hitting SQS directly through API Gateway.
Yeah, I think it's more to do with just extensibility in terms of if you put your API gateway endpoint to EventBridge, you can essentially leave that in place. And if the rest of your infrastructure changes over time, you're simply changing targets within the event bus itself. Personally, I find it easier to do that simply because API gateway integrations, can be harder to deploy and test because you have VTL and other things that are moving there. So from my point of view, I like getting the event straight into EventBridge. And you can also at that point then potentially add new targets as well. So another trick I commonly use is to log every single event to CloudWatch. And so that creates a secondary target, which I couldn't do easily if I was natively just connecting the two services.
Nice. And we have one last question about whether there's a nice way to sort of visualize the event flows through a system instead of just digging through the logs of individual services.
Yeah, I think, it depends on your application and what you're building, but observability is obviously a huge factor. There are a lot of different open source tools that I've seen people using with EventBridge. And I think Ben has one as well, which is pretty amazing. And then internally, there's X-Ray, which you can apply with lots of, for many of the different serverless applications, gives you good visualizations of what's going on. CloudWatch Logs Insights has some really helpful querying that I don't think that many people are aware of. So if you have log files in lots of different groups all over the place, you can query across those logs. That makes that a little bit easier. And then also there's lots of partners that produce really good visual ways to step around your application. People like Stackery, huge Lumigo has some good applications as well. So it really depends on your workload, but there's definitely quite a few different options out there.
Yeah, there are a lot of third-party options you can go with. I think the thing you mentioned about Ben, he's one of the co-organizers of this meetup. There's an open source tool, if you're interested, called SLS Dev Tools that you can look at.
Yeah.
But thank you, James. That was all the questions that came through. So we'll pass over to Sarah. But if you're ever interested in giving a talk again, we'd be very interested in having you.
Oh, thanks for having me. I'm always happy to come and chat some serverless, but feel free to contact me anytime at all with any questions you have. I'll do my very best to help. Thanks so much for your time today.
Nice. We'll talk to you later. If you share your screen, Sarah, we'll pop.
Hi everyone. I think I'm starting now. So thanks James for a really great talk. It's going to be a tough one to follow. So today I'm going to be talking about building a scalable chat app using AppSync. It's a project that I've been working on recently with a client. So let's jump in. So just to talk through what I'll be talking about, I'll be going through the motivation behind why we're doing this, the requirements that the client set. We'll jump into a quick demo of what we did build, and then we'll get down into the details with the architecture. We'll talk about GraphQL and AppSync, and then we'll go into a bit of a full feature breakdown of what we worked on. So the client is a leading webinar, webcast, and virtual event provider. So they essentially provide video conferencing to big clients, and they have lots of traffic to the website for that. And the client is called Workcast, so go check them out. It's been really cool to work with them. And thanks for letting me share this with the community. And so the business scenario that we're faced with, like many other video conferencing companies such as Zoom, was that they had a steady flow of users throughout before March of 2020. And then when March hit, one second. Sorry. So when March hit, they obviously had a huge spike in users, and as you can see, Google trend search for video conferencing like shot up, and basically the users at Workcast shot up as well, and the existing backend needed to take that load. So that was the task that we were faced with. They were essentially hitting a bit of a limit with how many people they could handle on the website, and they needed to accept that extra load on the platform. So the result that we came up with, we needed to create a scalable chat app that was part of the existing system, but it needed to cope with the load. So what we decided to do was a minimum viable migration. And essentially what this is taking the existing backend and then taking small features of this, such as the chat app, and deploying quickly so that we start to reap the benefits of that scalability, because to migrate the whole backend at once was going to take a long time. So it was just about getting onto this quickly and moving things through and deploying quickly. So that was the aim of the game. And the requirements that were set by the client, we needed to scale to 250,000 users. We needed to release quickly, as we've mentioned, and we needed to train up existing developers on the project who were .NET specialists. So we needed to come up with a solution that was going to do all of this very quickly. Just to jump in with who am I? So I'm Sarah Hamilton. I'm a cloud developer at Theodo UK. I'm also part of an initiative called Embolden Her, which is about getting women in tech to become leaders in tech. It's something that I'm quite passionate about. And I also thought about what can I tell you about my interests? And I looked through my camera roll and I realized that I've just spent the whole of lockdown with this cat and doing jigsaws. So I thought I would just add that in, given that I haven't actually been doing too much else other than coding. So anyway, this is what we built. So this is one part of the demo. So a part that I really enjoyed building was emoji reactions for the chat app. And that's the feature that we'll be breaking down towards the end of the talk, and how we did this so quickly. Another key feature of the talk was, so if you can see here, we have a webinar attendee on the left and a webinar host on the right. These are in two separate browsers. Now, when a attendee submits a question, it comes through straight away on the webinar host screen, and vice versa. When the webinar host replies, it comes through straight away on the attendee screen. So it's all about those like quick reactions, and essentially we used AppSync to do this. And I speak quite passionately about it because I've really enjoyed working with AppSync this whole time. So we'll go into that. So for the architecture, it's actually quite a simple one for this particular app within the system. So we have AppSync at the center of it all, and our data source is DynamoDB. We use this because obviously it scales hugely, and we also used AppSync because of the way that it connects with Cognito user pools. So that was really nice to set the permissions for the attendees and the hosts. And then we hooked this up to a front end, which we did in React, and we used the Apollo client to speak to the GraphQL server AppSync. So before we dig into the feature work, let's discuss what GraphQL actually is. So it's a query language for APIs, quite similar to REST in that sort of sense. But what the website likes to claim is that you get exactly what you need, nothing more and nothing less. How I actually found an analogy online, and I quite like this one. So Whereas with REST, you need to hit, say, 3 separate endpoints for 3 separate requests. Whereas for GraphQL, you only need to hit 1 endpoint for all of your requests. And the example given here is that if you want to go and get pizza, groceries, and dry cleaning, then you need to go to each of the different stores yourself, so 3 times. Whereas GraphQL is more like getting a personal assistant to go and do it all for you, or maybe a bit like Amazon. And so that's essentially a nice benefit of GraphQL, is that everything's coming back in one request. The other thing is that it solves the n+1 problem of underfetching. So you don't need to send a request off to one endpoint, then get items back to then use those to send another request to another endpoint. What you're doing, you're just getting back everything that you want in that one request, and you're not getting any additional items because you just define what you want to get back. This is just kind of clarifying that a bit more in a diagram. So you can just see that with the REST API, you're just hitting different endpoints for different requests, whereas for GraphQL, it is just one endpoint, and you just specify what you want to get back in your request. So GraphQL is all based upon a schema definition language. So firstly, we have queries. We have queries, mutations, and subscriptions as part of the schema definition language. If we start off with queries, it's analogous to a GET request in REST. And so for our example, if you're a host and you want to get all of the messages for a particular event, and then essentially you set up your query like this, and you say get messages, we pass in the event ID argument, and then we return an array of messages. And if we move on, then mutations are very similar to post requests in REST. And for this one, if an attendee wants to send a message, then we need to define what event are we sending the message to and the message that we're sending. And then we can return the message back. And lastly, this is kind of the fun stuff, the real-time updates. So we can define subscriptions. And a subscription essentially subscribes to a mutation. And so when the send message event happens, we can define our subscription so that for this example, when a message is sent, then the subscription gets triggered to update the information on the host end. So that's how we get our real-time subscriptions. And essentially, it's setting up a WebSocket. And so then where does AppSync come into this? So AppSync is a GraphQL server. And the nice things about it is that it has Cognito-based authorization. It has scalable WebSockets, which obviously we needed with wanting to scale to 250,000 users. And it has a nice integration with various databases, including DynamoDB, which was key for our project. And so just to dig into authentication a little bit more, you can just see how simple it is to use. We had 2 Cognito user pools, and we had one called attendees and one called hosts. And you can just see that we can authenticate the attendee to send messages, but we can only authenticate hosts to get messages. So we don't want other attendees to be able to get everyone's messages because we want them to be private. So it's just very simple to set up the authentication in that sense. So using VTL, once we've actually sent off our request from the front end, we need to do some logic to actually query the database. So in this case, we're doing our put item, so we're sending the message, and we want to put that into the database. Now, VTL is notoriously difficult to work with. Luckily, AppSync provides templates that do kind of most of the work for you. But if you want to do really complex logic, then I would suggest using Lambda. So when I wanted to add the emojis, I just opted for Lambda because I found it to be a nicer developer experience, as you can just do all of that in JavaScript. But if we go back to the VTL item, this is just based from a template, so it really wasn't too difficult. the nice thing here is we're doing a put item, which is just classic DynamoDB, putting one item into the table, and we set the key to be PK and SK, which we define up here depending on our Dynamo schema. The nice thing about how it hooks up with Cognito is that we can get information about the user in the VTL from the claims of the identity from the Cognito. So here you can see that we're accessing the email purely because it's been authenticated with Cognito, which is really nice. And then in the response mapping template, we return the result back for us to do whatever we like with. So moving on, this is kind of my full feature breakdown. So at one point in the project, the client was very nice and let us do a 3-day hackathon. And I decided to do emoji reactions because I just thought it was quite fun. Obviously, other platforms do this. And I challenged myself to do this quite quickly, but I wasn't too worried because I know that building things with AppSync is often very quick. So you can see that in the demo here. So I'll break this down into front end and back end. Just for a bit of background, I used a free library called EmojiMart, and you can see the items that you get back when you do click one of the emojis. The important one here is the ID, because we'll be using this to populate the database. And so there's very little code in the front end. We use the Apollo client to do a lot of this. Namely, we use the use mutation hook from the Apollo client. We pass in the arguments that that the mutation needs to take. In this case, the event ID, the SK, and the emoji ID, as mentioned just then. And then we just add this this function to the button on click. And so what you can see here is that when we actually trigger this, after some custom logic in a Lambda, this is the result in DynamoDB. So you can see that we have a map of the IDs with the number next to the ID to show how many reactions of each one is there. So it's all like really quite simple. And so the last thing to update is we need to make sure that when we do click the emoji, that the number goes up. So this is where subscriptions come into play. So we use something called subscribe to more, which is a part of what comes with a use query. So you can see here the definition is to execute a follow-up subscription that pushes updates to the query's original result. So in this case, we have a list of messages. These have come in through a use query of just listing all of that person's messages. And then what you can see here is that we have a subscription set up so that when an emoji is added, the subscription is called, and then we update the cached messages through some custom logic here, just simple JavaScript to update the messages that are already there. And that's about it, really. It was really nice to work with and a really enjoyable few days. So I would really recommend having a play around with AppSync. Lastly, the boring bit, so the pricing. So it's $4 per million for querying data modification operations. So I think in comparison to API Gateway, which is 3.5 per million, it's a little more expensive, but given the fact that you don't need to overfetch, it can actually work out cheaper because you don't need to do multiple requests for what you want. And then it's $2 per million for real-time updates, such as the subscriptions. And so the verdict, I think that AppSync is awesome. As you can tell, it's been really fun to work with. Upskilling the new team has been pretty smooth. It's obviously quite a big paradigm shift from using like a .NET to serverless. But in general, the AppSync part of this has been quite nice. The VTLs are quite painful, but as I say, there's a bit of a get out by using Lambda, so that's quite nice. AppSync is scalable, which is great for what we needed it for, and you can develop fast. So that's the end of my talk. Shout out to Theodo. They're a great place to work, and I'm working on a really enjoyable project at Workcast. Thanks, everyone.
Nice. Thank you very much, Sarah. We do have one question about setting up AWS AppSync's client with Apollo. I won't get you to bring up your code, but do you have any any experience with that? Or I can't remember if it was already set up when you joined the project.
AWS AppSync client with Apollo client. I'm not so sure. Did you set it up, Alex?
Yes, so we can send you a link maybe in the comments after. It's quite simple. There were maybe a few gotchas, but there's some documentation on that. But that's the only question. If anyone else has any questions, you can quickly put it through. But I guess I'll ask you. I'll ask you what's like. Are there any gotchas or hard parts about AppSync that you've struggled with, or any parts you think could be a bit nicer?
I mean, I think that the most difficult part was probably the subscriptions. So just getting your head around actually understanding how it works. But I think that once you work with it a few times, it's pretty nice. And then I think, as I've mentioned, VTL is just kind of notoriously difficult. Whenever I have to write some custom VTL, I kind of dread it a little bit. But that's when you can kind of just get out and use Lambda. So it's not too much of a problem. And I think that if you are good at writing VTL, then no problems for that person. But
all right, thank you so much for giving that talk, Sarah. And if it wasn't already clear, I work on that project with Sarah, so it has been fun, and I am a big fan of AppSync.
Yeah.
Before we wrap up, I just want to thank Senzo and Theodo for sponsoring. Senzo runs something called Homeschool, where you can do courses. I think Ant might be running one soon on getting up to speed with Node. Node is probably the most popular runtime for Lambda, so it can be very, we find a lot of developers start using that for the first time and need to get up to speed. But he also has a lot of other really cool courses on different serverless things, and works with a lot of other AWS serverless heroes like Yan Chao. And Theodo, me and Sarah work at Theodo. Workcast is the client that was in the slides that Sarah was talking about. But if anyone out there has any troubles with developing with serverless, we have serverless teams and we're available to help. There has been one last question, actually, Sarah, that I'll ask you that's popped through about your thoughts on single table design.
Well, I think that it's great. I'm fairly recent to development in the past few years. So I've actually only worked with NoSQL databases. So I actually haven't gone through that transition period from SQL to NoSQL. I think it's great. I think that if you're working with a product that's scalable, then single table design is the way to go. But I also don't think that if there's a case, I don't think you should try and force it, basically. I think you should try and stick to single table design. If it doesn't quite work for you, then maybe you might need an extra table. But yeah, generally, I really like it.
Yeah, on this project that we've been working on, a big part of it's training, and Dynamo is often one of the hardest parts to training. So single table design's really powerful. That's definitely what to aim for. But sometimes you do just good enough can be good enough, and you want to get something that works. But I definitely recommend Alex Debris' DynamoDB book for anyone interested in learning more single table design.
Yeah, and I'll actually post a link to I read an article the other day that he wrote about just single table design, and I sometimes find that a bit easier to digest, like a smaller section. So I'll post that blog into the chat.
Nice. Well, thanks everyone for watching. We will see you all hopefully at the next meetup.
Yeah, thanks everyone.